Hey guys, welcome to another video for pre-calculus. In this video we're going on another calculus topic. This is extreme value theorem. So I want to kind of talk in detail as to what exactly this means and what we're going to be working with. And then I'm going to have a word problem that we'll work out at the end. So the definition of an extreme value theorem is if a function f is continuous on a closed interval ab, so it's a closed interval ab, then the f of x attains both a maximum and a minimum on that interval AB. So here we have a full function, a graph, right? Some function. It's just a random one that I kind of drew out. And this particular definition is telling us that, well, just if you look at the graph in general, just as it is right now, and I were to ask you, to find the extreme maximum, the global maximum, or the global minimum, meaning as you look at the graph, what is the highest point that this graph goes, just on what is shown here. And we'll assume that it doesn't go any higher than or any lower than what's shown here. So if I were to look at this and I were to ask you to find the global maximum, you would just look on the graph and you would find, let's assume that this is the highest point on the graph that it will ever attain. So that would be the global maximum, right? Maximum. And then I would ask you, find the minimum, the lowest point that the graph goes on, and you could assume that this is it right here, the minimum. This is the global minimum. All right. Now going with this definition, here, let me erase what we have here right now. Going with this definition, what if I were to ask you now to find a local minimum or a local maximum? And that's something that you would have to narrow down what you're looking at on the graph. Instead of looking at the whole thing as a whole, you're only looking at the graph based off of whatever interval the problem has given you. And let's just assume that this is one right here. This is point A, and let's call this one here point B. All right. So this is our interval. So that means in our graph we are ignoring everything except what is within this interval. So I'm going to highlight it in gold here. So that's the only part of the graph that I am now paying attention to. And so given that, now I would ask you the same question. Now find the local minimum on this graph. So what is the lowest point that this graph touches? And that would be this one right here. And then what would be the highest point? That would be that point. Now these points also have another name. They are also called critical points. Okay? Now the way you find critical points on a function, there are two ways. Number one, to find the first rule to finding a critical point is that you find the derivative of that function at 0 or where that function is undefined. Okay? So again, that when you were given a function, you find the derivative of that function and then you find where that derivative is equal to 0. Now, what does that mean exactly? Now, if you go back to the definition of what of the derivative is, when we're looking for derivatives, we are looking for the tangent lines of the graph, right? So if I were to find a derivative of this point of the function, I would find the slope of that line, right? Of that particular point. If I were to find the derivative of that point of the function, I would find the slope of that line. Now, let me erase those lines that I just drew. Okay, so what if I were to find the derivative of that particular point, right? That critical point. Well, if I were to find the tangent line of that critical point, that slope would be a horizontal line. It would be 0. And that's actually the truth for every single critical point here. Okay? Every critical point. Now you notice that the critical points come at points where the graph typically is making a turn, right? So it's going up, 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 up. So the slope is positive, and then the slope is 0, and then the slope is negative, negative. Because every point on the right of that point, on the right of my red point there, every point is going to have a negative slope, every tangent line from that point on. And that, again, it continues on, negative tangent, and then here you have a 0 tangent, and then on the right side of that you have now a positive slope. So every time that the slope goes from negative to positive, the change, that would be a critical point. Now, since we're looking at this from an interval, right? If I'm just looking at it from here, oops, I erased all of that. Let's go back. Okay. So since I'm looking at this interval here, and I'm going to redraw it here in red, so that's refocus on that point. I have two critical points, and it's, let me write it in blue now. It's this one because the slope of that point is 0, and the slope of that point is also 0, which is my first definition of what makes a critical point. Okay? Now, real quick, let me actually draw another graph where there's an exception to what I just said. Because not every critical point necessarily is a point where the graph is here, where the tangent line will be 0 necessarily, because, here, let me draw another one. Let's say I have these 2 points as my my interval. This is my A and this is my B, so it's interval A, B, closed interval. Well, what would be my maximum and minimum point at in this interval? Well, it would be this one is my maximum and this one is my minimum. Now, with the exception of this one here, this one does show where your graph kind of changes. I mean, the slope is 0, but with this one here, your slope will not be 0. There's actually a slope there. So it's not always necessarily the case there. Okay, so let's look at an example here. Okay, so the word problem here says that the height h in feet of a car traveling along a track of a roller coaster can be modeled by this equation here. H of t is negative 1/3 t cubed plus 4t squared plus 11 over 3 on the interval of 1/12, where t is given in seconds. All right, so find the maximum and the minimum heights. So I'm looking for critical points once again, right? And if you remember the rule for finding critical points, the easiest way is find the derivative. So I want to find the derivative of this function right here. I want to find the derivative of h of t. Okay, so let's find that derivative. T cubed plus 4t squared plus 11 over 3. So that means I'm going to multiply the coefficient by my exponent. So that's going to be, that's essentially just 1, right? So it's going to be a negative t, and this is going to be minus 1t squared, plus 8t, and then plus 0. So that's it. That is the that is my derivative of that function. Okay, so now that I have my derivative, now what I want to do next is I want to find where this derivative will be 0. So I want to zero this out. I want it to be 0. So that means 0. Okay, so since I want to zero out my derivative, I want this to equal 0. Okay, so my first step here, I can see that I can factor out a t. So I'm going to factor out the t, and I'm also going to factor out that negative sign. So that'll give me t on the inside and then minus 8 on the inside. Because if I factor in negative t to t, that'll be negative t squared. Negative t times negative 8 will be positive 8t. So in that case, I can see I can zero that out. That'll be 0 divided by negative 1 or multiplied by negative 1. Positive t equals 0. So that's one of my critical points. And then t minus 8, t equals 0. That's going to be t equals 8. So there we go. I have found my 2 critical points on my function. Okay, that means something is going to happen there where my graph is either going to take a turn, where it's going to go from being a positive slope to a negative slope, or it's going to be from being a negative slope to a positive slope, one or the other. Okay, I don't quite know for sure yet because I don't know what the graph looks like. I'm just doing this all mathematically. Now, something to take note of. Let's go back to the word problem, and I'm going to highlight it in green now. What is my interval there? It's 1/12. So on my graph then, that means on my graph I am paying attention to everything that's between 1 and 12. And you'll notice here that one of my critical points is at 0. So 0 is to the left of that of that interval. So I can actually ignore that for now. I don't really need it, other than to make note of that's one of my critical points. But 8 is in that graph. So since my interval is 1 within 1 and 12. I want to find what my function, the value of my function at these 3 points. And if I go back to my original function, it's kind of long. It is h of t equals negative 1/3 t cubed plus 4t squared plus 11 over 3. And then my t, so everywhere I have a t, I'm going to replace it with a 1, an 8, and a 12. So that means h of 1 will be negative 1/3 1 cubed plus 4 times 1 squared plus 11 over 3. Okay, I'm actually going to work these off on the side just to kind of save time on the video. And then h of 8 will be negative 1/3 8 cubed plus 4 8 squared plus 11 over 3. And then last but not least, I have h of 12, which is negative 1/3 12 cubed plus 4 12 squared plus 11 over 3. Alright, so I'm going to work this out off to the side and then just kind of give you the answers here. So let's see here, what will my answers be for h of 1? Okay, so here are my answers for those three values. And so now one real quick thing. Notice how I plugged in my values into the original equation. I did not plug it into my derivative equation because remember, my derivative equation serves one function, and that function is to help me locate critical points, right? That's going to help me find the maximum minimum. But when I plug in those values, the interval value and the critical point value into the original function, I'm plugging it into the actual function I'm looking at, not the derivative of that function. I'm not looking just at the tangent line, right? Remember that? Remember that's what that is? The derivative is nothing more than a tangent line to that function. I actually want to see the function, not just a tangent line. So, all right, let's plug these into the graph here, up here, just to kind of get a general idea of what that graph is going to look like. So at 1, my h of 1 is going to be 7.3, so I can just kind of guess 7.3 there. And at 8, it's going to be all the way up here at, so h of 8 is 89. H of 1 is 7.3. And then h of 12 is 3. So it's down here. So now I'm going to connect my dots just to see the function, how the function looks like in that interval. Right, so I'm going to highlight it in yellow so I can actually see it better. Okay, so there's my points. That's what my graph looks like. So from that graph, from that interval, I can see that my highest point is at 89. So this is my maximum. Here, let me highlight that. This is my maximum. And then I have a minimum here. So this one is 7.3, but this one was, what was it? 3.67. 3.67. So this was my minimum, and this was my local maximum, local minimum, with my critical points at 8 and 0, but the only one that really applied there was 8 because 0 was over here and 8 is within my interval. So let me go back to the original question on my word problem. So the height in feet, so how high is the cart, the roller coaster? At 8 seconds, it reaches a maximum height of 89 feet. Okay? At 1 second, it's at 7.3 feet, and at 12 seconds, it has come down pretty fast, and it's now at 3.67 feet. So that's kind of how you work that out. This is how this particular type of math is applicable, because it helps you find the minimum points or maximum points of a given function, or in a given interval. Okay, I really hope this helped. Good luck in your studying, and thanks for watching.